Oh, hello there. I'd like to take you on a journey of our statistics project that we completed in the past couple of days. And it's important that I tell you why we chose to do this. In 2017, the year of the 10th anniversary of the iPhone, Apple decided to release three new models. Two of the models were an evolution of previous editions and were named the iPhone 8 and 8 Plus. The third model, named the iPhone X, was Apple's revolutionary take on the smartphone, with equally revolutionary price that was $300 more than the iPhone 8. When new phone buyers were faced with the new selection, the prevailing question was, is the iPhone X really worth the extra money? While we recognize there are many metrics by which to measure how good a phone is, we decided to focus on how quickly a phone could make a call to a landline.
Gravy.
Mr. Sandman, bring me a dream. Make him the cutest that I've ever seen. Give him two lips like roses and clover. Then tell him that his lonesome nights are over.
Gravy make a splash like.
So our question was, on average, is an iPhone X or an iPhone 8 more efficient in making calls to a landline? Our hypotheses are these. Here, where mu sub x is the amount of time it takes from when the call button was pressed on the iPhone X to the first ring on the landline. And mu sub 8 is the mean amount of time it takes from when the call button was pressed on the iPhone 8 to the first ring on the landline. We collected data within a 2-hour period of time. To begin with, we wrote the numbers 1 to 4 on individual paper slips and placed them in a hat. We then drew the pieces of paper out of the hat, and the order that they were drawn out in determined what phone was used to make calls during that time period. The first and second time periods that were drawn used the iPhone 8, while the third and fourth time periods drawn used the iPhone 10. After conducting the hat method, we randomly determined that the time periods from 0 to 30 minutes and 1 hour to 1 hour and 30 minutes would use the iPhone 8, while the 30 to 1 hour and 1 hour and 30 minutes to 2 hour time periods would use the iPhone 10. After the iPhones were randomly assigned to their 30-minute period of time, we would make a call with the assigned mobile device every 2 minutes from the iPhone to the landline and record the amount of time that it took to make the call. Potential sources of error were accounted for by ensuring both phones were disconnected from Wi-Fi to prevent Wi-Fi calling, and both phones were connected to the same wireless service provider, which was Verizon. Additionally, both phones were made calls from the same location and to the same landline phone.
Hi. So our data collection, what we got for that, here's our summary statistics. And here is our histogram that we created from the summary statistics. So let's go over the histogram for a little bit. The iPhone X histogram has approximately normal shape, a center of about 2.4, a spread from about 1.4 to 3, and no outliers. The iPhone 8 histogram shows an approximately normal shape, a center around 3.6 seconds, a spread from about 3 to 6.8 seconds, and one outlier at 6.8 seconds.
We are conducting a two-sample t-test for the difference between mu sub x and mu sub 8 at alpha significance level 0.05. Our conditions for inference are met. The condition for randomness was met because the iPhones were randomly assigned to different time periods as explained in the data collection section. The condition for normality was met because 30 calls were made with each device, which satisfies the central limit theorem. The condition for independence is met because it is safe to assume that more than 300 calls are placed by an iPhone 8 and an iPhone X every 2 hours. Here are calculations.
To conclude, because the p-value of 1.92 times 10 to the negative 12 is less than the alpha significance level of 0.05, we reject the null hypothesis. Therefore, we have convincing evidence that the iPhone X does take less time to make a call
from the phone to the landline than the iPhone 8 when using Verizon as the wireless service provider. As we did not take a random sample from the iPhone X's and iPhone 8s, we cannot generalize our results to all iPhone X's and iPhone 8s. We also cannot generalize our results to all landlines because we only collected data using a single landline. Transition. Overall, collecting the data was very straightforward and easy, and very little errors were made during the calling process. Some human error may have been present because the times were recorded by hand, and there may have been some delay between when the call button was pressed on the phone to when the timer was started. However, because we took a large number of samples, the human error should be similar for both phones.
That was easy.